I welcome you all for this lecture series on deep learning. In this lecture, we'll see one example problem by using a CNN architecture, that is layer by layer explanation. We'll see to it. For this case, we have taken 5 cross 5 input image and a 3 cross 3 filter. Before going into this example, first all we should know about this architecture. This is the CNN convolution neural network architecture. This architecture consists of input image, convolution layer, activation functions, pooling layer, fully connected layers, and softmax activation and output layer. Thus, all you know that a convolution neural network (CNN) is a type of deep learning model designed specifically for processing grid-like data such as images. It starts with an input layer that receives the raw pixel values. The data is then passed to one or more convolution layers where small filters slide over the input to detect local features such as edges, corners, or simple shapes. These filters are automatically learned during training. Next, the pooling or a subsampling layer reduces the dimensionality of the feature maps, which helps in lowering computation and preventing overfitting, and making the network invariant to small translations in the input image in this stage. After several convolutional and pooling stages, the resulting high level features are flattened and fed to fully connected layer, which combines the features and learn complex nonlinear relationships. In the final stage, an output, that is softmax layer, converts the learned values into the probabilities for each class, allowing the network to make a final decisions or the classification. This is what about the CNN architecture. Now we'll see one example problem. So in this problem, we have taken the one a single channel image we have taken. That means a grayscale image, black and grayscale image we have taken. So this image is the 5 cross 5 input. This image size is 5 cross 5 image. So this will act as the input layer to the CNN. This we are going to fit into the input layer. Then we are going to convolve with this image with the kernel. So what it will do is, here the convolution is performed by sliding a small matrix called a filter. This we can call it as a filter. This filter size is 3 cross 3, or this the filter, otherwise we can call it as kernel, over the input image, and computing the element wise multiplication and summation between the filter values and the overlapping part of the image. At each position, the filter is placed on top of the image patch of the same size, and each corresponding pair of values multiplied and then added together to produce a single number. This number becomes one element in the feature map. The filter then moved across the image according to a fixed stride. The stride we can call it as, here in for this case we have taken the stride it as 1 by 1 it will move. Stride we can call it as, it will be moving, and the same multiply and the same as some process multiply and some process is repeated and the entire image is covered. In this way, the convolution extracts useful local features such as edges or patterns from the image and converts the raw input data feature map that can be further processed by the network. Here we have taken the 3 cross 3 filter, the stride size is 1, no padding is we have involved, we have not involved any with the any padding. So in this case, the stride the kernel over the image and the perform element wise multiplication and summation. That I'll tell you how it will be happening. So here three, first we will consider 3 cross 3 image we have, that is a kernel we have taken. So this we are going to multi this in the image, the first 3 cross 3 we are going to take. First, how we are going to map means this going to be convolved with this kernel. means how it will be done means 1 cross 1. This number, this 1 is multiplied with 1. So 1 cross 1. See here 1 cross 1. Here we have given plus. Next we have to, so right, then we have to write 2 cross. This 2 cross 0. Then plus 3 cross 1. 3 cross 1. Then plus this 0. 5 cross 0 plus 4 cross 1. So in this way, convolution means multiplication and summation. Plus 3 cross, what is the value here? 0. Then plus 1 cross 1 plus 0 cross 0 plus 1 cross 1. So we have to multiply and add. So here we have done it. The value we got it. The 10 we have got it. This is the first stride. So one by one we will be moving. The second step, we are going to consider the second 3. Stride 1 means one step, one by one. Single step we are going to consider. So in the second step, we are going, the same procedure will be repeated. 2 will be multiplied with 1, 3 will be multiplied with 0. So 2 into 1 plus 3 into 0 plus what is the value? 4 into 1 plus 4 into here, this value 4 into 0 plus 3 into 1. 3 into 1 plus 2 into 0. 2 into 0 plus 3, 0 into 1 plus 1 into 0 plus 0 into 1. The value we got it in this case. So 2 plus 0 plus 0 plus 4 plus 0 plus 3 plus 0 plus 0 plus 0 plus 0. So the value is 2 plus 4, 6, 6 plus 3, 9. 9 we got it for the second stride. Similarly for the third. So here we got the cover region, the second cover region. The third cover region is, this is the third cover region. So I am deleting, and the third. So up to this, the first thing is over. So similarly, this is the third step, and the fourth step we are going to consider here, and this is the fifth step, and then finally this should be the sixth step. So we are going to fetch with this and match with this, and we are going to multiply and add. So if we are doing like this, we are we are calling it as what we are cutting, and we are manipulating the image, we are calling it as the cover image. So finally we got, so how many steps similarly we are getting means 5 cross 5 means 5 minus 3 divided by 1 plus 1 is equal to 3. So we are going to get the output value is 10, 9, 14. This is the resulting future, 10, 8, 12 and 12. The next step is, so in this case, I have taken the stride value is 1. If suppose if I am taking stride equal to 2 means 2 steps, instead of moving one step, it will be moving into, so first case, the first stride 2 if I am taking, the in this case the first phase 1, stride 2 if I am taking, instead of going into single step, it will be moving to 2 steps like this. So I'll be showing you one animated visage. This is the stride 2. See here, 2 steps it will be moving. So we are going to get 4 cross 4 in this. Hope everyone understood. So activation function. So after doing all those things, here we have to apply the activation function. In this example, I have taken ReLU function, ReLU activation function. So after doing convolution, we are going to apply the activation function to introduce the non-linearity. The most common activation function, what we are using in the CNNS convolution neural network is ReLU. ReLU, all you know that rectified linear unit. ReLU of x means, suppose I got the value like this 9 minus 4 6 or 3. After applying ReLU function, my function would be 0, 9, 9, 0 and 6, 3. It will omit the negative values, maximum of 0, comma x. So in this case, in our example, we got only the positive value. So we will not worry about the negative value. So all values will be taken as it is. 10, 9, 14, 8, 10, 8, 12, 12, 12. So if any values was negative, here if suppose any values are negative, this will be replacing it as 0. But in our case, fortunately, all values are positive. So we are going to take all the values as it is. Next, pooling. After the activation function, we have to apply pooling. In order to reduce the down sampling, we have to go for it. So choose the pooling type and window size. For the pooling, we are going to choose 2 cross 2, and what we have taken the pooling is the maximum pooling, and the stride is 2, which means the window jumps 2 steps. Stride 1 means it will jump into 1 step jump. 2 means 3, 2 means 2, 3 stride value is 3 means it will jump into 3 steps. So here the stride 2 cross 2 window over the feature map, and for each window take a maximum value in the window. Maximum pooling or min pooling, whatever the value that is type we have taken, accordingly we will select. 2 cross 2 will take. So here 2 cross 2, it will be, in this case, if you are taking, what is the maximum value? 10. And here if you are taking, in this case, the value is 14. And similarly, if you are taking this, the value is 12. And in this case also the value is 12. So finally we got the value, it has 10. So 10, 9, 8, 14 we have taken. So in the first cover, in this first cover, what is the maximum value? This is the first cover. We are calling it as the cover. This is the first cover. In this case, what is the maximum value? 10. Similarly, in this case, 14. So accordingly, we have to select. So 10. Hope everyone understood. 10, 9, 8, 10, 9, 8 and 10. So the maximum among 10, 9, 8 is 10. So the first pooled value is 10, second pooled value is the 14, 12 and 12. So in this case, we are going to, finally we are going to consider 10, 14, 12 and 2. This is the final pooled values by combining all the, by considering all the values one by one. So this pooling, what it will reduce is 3 cross 3 again. First 5 cross 5 reduced into 3 cross 3. This 3 cross 3 again after pooling reduced into 2 cross 2. So dimensionality is being reduced. It reduces the spatial size and retains the most important features. Valid features only it has been taken. So this feature values will be given to the hidden layer. So the vector is fed to the dense, that is fully connected layer, where each element is connected to every neuron in the next layer. These neurons learn global features for the classification. So this will be given as input to the hidden layer. So how means it? So my neuron, this is the input features after finding out. So we are going to consider 10, 14, 12 and 12. I have taken the hidden layer values 4. All you know that each layer will be connected with all the neurons. So it will be connected. You have to connect like this. All the input features will be connected with all the, so that only we are calling it as the fully connected layer. Fully connected layers. It will be connected like this. And each connection is associated with what? The weight value. Each connection is associated with the weight value. So if suppose if I am finding the value 10 mean, this 10 could be, so first neuron if you are considering, this is the neuron 1 in the hidden layer, we have to calculate 10 into 0.20. Here all the values should be value multi 10 into 2.0. See 10 into 2.0 first step. Next 14 into 14 should be multiplied with what? This 14 should be multiplied with this value, and then 12 will be multiplied with 0.15 and x 12 with multiplied with 0.4. Got it? So if you are multiplying and adding, you are getting the value 6.4. ReLU, if you are applying, this is the positive value, so you are getting 6.4 only. Similarly, for the neuron 2, this is the neuron 2. Neuron 2, if you are taking 10 into minus 0.010, 14 into 2.5, 12 into zero point 0.3, and 12 into minus 0.20. So if you are multiplying, you are getting the value like this, 3.7. So ReLU, if you are applying 3.7. Similarly, the third neuron, this third neuron is also connected with all the neurons. So 10 into 0.35 plus 14 into minus 0.20 plus 12 into this 12 into 0.010 plus 12 into 0.15. So if you are multiplying and adding, here also we are getting 3.7. Similarly, for the fourth neuron, what you are going to get? Here 10 into, this is the fourth neuron. 10 into 0.15 plus 14 into 0.30 plus 12 into 0.05 plus 12 into 12 into 0.25. So all the weight values along with this input should be multiplied, and we have to calculate the value. Here also we are applying the ReLU. The value is positive since we are getting the same value. All four neuron outputs we are getting it as, what is the value we are getting? 6.4, 3.7. Value only we got it, but we didn't apply the activation function. We have to apply the activation function 9.3. So the output for this example, so four neurons we are getting, and here I am going to take three outputs. All should be connected, all with every neuron, and similarly here these values should be connected like this. So all you can understand. So three predictions we are going to have: output neuron 1, 2, 3. Output layer has three neurons. So for example, I have taken three output neurons. Any type, any number you can take it. Because the hidden layer has four neurons, the output layer has three neurons. The weight matrix must be, again I have taken the weight matrix for the output value. Okay, so four output here. This should be connected with the four values we need. Everything what we did in the previous step, we have to calculate. 6.4 into 0.2 plus 3.7 into 0.4 plus 3.7 into, like that we have to multiply. See, all the values I have multiplied, got a 2.94, 2.68, and 1.615. Three neuron output. But now the final step, after calculating the value, we have to apply the activation function. Here I have used the softmax output function. Softmax functions we have taken. So in this case, so we found out the value for this 2.68 and 1.615. So this is the output layer raw scores logistics, and then we have to apply. The output is fully connected layer is passed through the softmax function to convert the raw scores into the probabilities. This is the formula: e power zi divided by summation of e power zi. So this value between 0 and 1, the probability. The classes with the highest probability becomes the final prediction if you are already given the targeted value. Here the softmax function is this. We know that the first value is 2.94, second value is so if you are finding out the value, we are going to get you use the calculator and found out uh, I have used the calculator and found out this value 18.92, e power 2.685 is 14, and here we have to sum up. If you are summing up 18.92 plus 14.66 plus 5.02, we got 38.60. So for each and every value we found out. First, what is the first output? 18.92 divided by this value. The second output is 14.66 divided by 38.60, and the third output value is what? 5.02 divided by 38.60. So we got it 0.4938 and 60. So the highest probability we can be giving it as the output 1. And I have, for your understanding, I have taken let me classify three classification: cat, dog, and horse. So in this case, the cat, dog is having the highest probability. The second highest probability is cat, and the third probability is the horse. So from the conclusion, the first probability, the output one, consider it as dog. The second, consider it as what? The second probability is this may be the dog, this may be the second highest. We have to compare with the, here only the value, not exact value, highest value. Prioritize 0, 1, 1, 2, 3. We have to give the first value. Highest probability is dog. The second highest probability is the cat, and the third value is the horse. So in this way we can classify. So the output layer produces what? Final classification result. So from the output, we can come to the conclusion that 0.493813, we are coming to the conclusion that output 1 produces, we are calculating and coming to the conclusion the classification is dog, highest probability, and the second value is what? 0.38. So 0.38 is the highest, second highest probability. We are coming to the conclusion that it is the cat, and the third value is the horse. So in this way, any number 5 cross 5 or 7 cross 7 or 9 cross 9 input image, and we have to consider whatever may be the the kernel value. So we have to proceed this step like this. So finally we are coming to the conclusion, whatever the targeted value given, we are going to find out. So in this case, so input image we have taken 5 cross 5, and conclusion we have applied it, and here we have got 3 cross 3. After applying the activation function and all, the pooling layer we have considered, the pooling function we have taken, max pool we have taken, and then the 4 inputs we have given as input. This is the hidden layer, we can call it as the hidden layer. Then we have applied the softmax value summation of e power j. Finally, we got the three outputs. We have predictions. The targeted values are given: dog, cat, and horse. Dog has given in the targeted highest probability. The second highest probability in our example is the cat. The third value is the horse. So in this way, it is very simple procedure to apply. Once if you are able to understand calculations, any problem to hope convolution neural network, the remaining things we'll discuss in the next lecture. Thank you.